the first node, there will be a pointer. There will be a pointer called as head or first. Head or okay. So this head pointer will hold the address of the first node. Okay, please note head here is not a node, it is simply a pointer. Okay, right? So this will point to this. Okay, I hope you have understood. So this is called as a linked list. So now let's create a linked list. Okay, right? What we will do, we'll implement a queue using a linked list. Very simple. Okay, so let's implement a queue using linked list. Program to implement queue using linked list. Okay, now I will trace the program also for you, so do not worry. Now in this case there is no need of size, because at the beginning the user will never give the size and we will not be knowing also. Okay, so there is no need of FP all this. So okay, right, and then we need a structure here, struct node. Okay, let the data be a string. So let the data be a string. Okay, maximum 20, and then node star link. Okay, right. So I want you to please pay attention this data. Okay, within the node here we are going to store the data as strings. Okay, right. So here we will store okay, and here we will store so like this the data will be stored in the okay linked list. Okay, right, I hope you are trying to understand. Okay, and this address is of the next node. So what is this node? So address of that is node star. Very simple. Okay, so this is node, so the address of the node is node star. Very simple. Okay, right, so we have taken one a structure okay called as node. Now so this ptr will name it as head. Okay, holds the address of the first node in the linked list, nothing but queue. Okay, right, the linked list here is nothing but queue. Okay, now these are the four functions. Okay, enqueue, dequeue, display queue, and okay display queue and the destructor. Now please note what we will do as usual. Please note we will insert the nodes at the rear end and we will delete from the front end, or you can do it the other way also. You can insert at the front and delete from rear. Okay, right, so this is also fine. So what we will do is we will insert at the rear and delete from front, and assignment to you people is you have the front and delete from rear. Okay, in both the cases the implementation will be for a queue itself. Okay, will be for the queue itself. Okay, so let's do it. Now I'm going to delete all this. Okay, yeah, so enqueue, dequeue, so all this we will do it freshly. Okay, right, right. So now here we'll first define the class. What is the class? Come again. The class is having, so this is not float, this is node. So node star head. Okay, so node star head. So in the at the beginning, what the queue will be empty. So how to mention the queue is empty? Head equals null. Head equals null. The queue is empty. Okay. I hope you are trying to understand. The queue is empty. Okay. Right. You can also make this a class. Okay. Right. But we'll see it in the next program. Let it be struct now. Okay. So now what did we do? A queue is created. We can say a queue is created. Okay, that's it. So in the constructor we have made the head equals null. Okay, a queue and empty is created, we can say. Okay, now here what we'll do, head equals null, we can say, and we can say the queue is deleted. Okay, and then enqueue is to insert one element. So to insert an element into the queue, that is nothing but a linked list, first you have to check if the list is empty. How to check if the list is empty? If head equals null. Okay, if head is null, we will simply add the node as the first node and we will return. If head is having only if the list is having only one node, we will add the node as the second node and we will return. But if the queue is having more than two nodes, then we have to traverse. Okay, first we'll go to the first node, from there second, from there third, and then we will insert it to the fourth node to the linked list. Okay, right? So if there are more than one node in the queue, we have to traverse the linked list. We have to traverse the queue. Okay, right? So these are the possibilities. So first possibility, if head equals null. What does it mean? If the linked list is empty. So in that case, what we will do, we have to first create I'm sorry, we have to first create a node. So we will take star nn new node. Okay, then probably we need a temporary variable. Okay, right, temporary pointer to traverse the linked list. Okay, right, equals null, and now we will say what, nn equals new node. Okay, so create a new node. That is what we did. So now next what we will do, nn of link equals null, link part of the new node null, isn't it? See, as soon as a node is created, it will have the link part, which is an address. Okay, that address, it should not be junk, so we will make it null. Okay, so now what we'll do, cout, enter the data of new node. Okay, cin, what we will do, nn of data. Okay, cin nn of data. Okay, so now the node is ready. So in this what we did here, in this statements, we have created a new node and we have stored the data, respective data, inside the node. Okay, so now the new node has to be inserted to the linked list. So here what we'll do, when the list is empty, we'll say head equals nn. We'll make the new node itself the first node. Okay, make the new node as first node. That's all. Then return. Nothing else you have to do. Okay, right. Now what we will do, if head of link equals null. What does it mean? If the linked list only one node. So in that case, what we will do, we will say head of link equals new node written. Okay, otherwise we have to traverse. Okay, so what we will do, while temp of link not equal to null, temp equals temp of link. Don't worry, I will will trace this program. Okay, we will trace the program, so do not worry. So temp of link equals new node, add the new node as the last node. Okay, right, check if you have reached the last node. Here move to the next node that we are doing here. Okay, right, okay. Okay, now DQ, when we cannot delete any element when the list is empty, when the queue is empty. So how to check? If head equals null. Okay, very simple. If head is equals null, we'll say list queue is empty, cannot delete an element. Okay, right, written, that's all. Okay, right, then what we'll do, if head of link equals null. So what is that? If the linked list has only one node. So if the linked list has only one node, so we have to delete it. So what we will do is, we will say cout the deleted node is, okay, the deleted node is, okay, of data. Okay, then delete the node by saying, then make the head equals null. Delete the node from the heap. Okay, make the linked list empty, because if there is only one element and when we have deleted that element, okay, the list becomes empty. Okay, right, otherwise what, the list is having more than one node, so in that case we need to traverse. So node star temp equals head. So what we'll do is, while temp of link not equal to null, check if you have reached the last but one node. Please note, we are not reaching the last node, we are reaching last but one node. Okay, so what you have to do, temp equals temp of link. Okay, temp equals temp of link. So now after coming out of the loop, where you will be at the last but one node. So please note, you will be here, last but one node, and you will have to delete this node. Okay, so how to get the address of this? You'll simply say temp of link. Temp of link is 4701, which is the address of the last node. Okay, right. So what we will do here, cout the deleted node is, or the deleted data is. Okay, temp of link of data. Now we have to delete temp of, that is the last node, and make temp of link equals null. So what is this? Okay, we'll delete the last node, make the link part of the last node null. Okay, that's it. Now display queue. When we cannot display, of course, when the list is empty. So what we will do, if head equals null, the list is empty. So here what we'll say, cout the queue is empty. Please note we are implementing queue using link. Okay, right? Written. Otherwise, what we'll do, node star temp equals head. Otherwise, we have to print all the. So we will say cout the queue elements are. Okay, the queue elements are. So here what we'll do, while temp not equal to null. So while temp not equal to null, cout temp of data. That's all. So then temp equals temp of link. So print the data and okay, check if all nodes are scanned. Okay, print the data of every node in the linked list. So here move to the next node. Okay, so this is the, now the solution is ready. Please note, now the solution is ready. Hope you people were concentrating and trying to understand what I was trying to write the code. Okay, right? If you see, if you have concentrated and learned when I am tracing the program, you will learn it fully. Okay, you will learn it without any doubt. Okay, now here we're implementing the queue. So queue star p equals new queue. Same thing. See, the the main function remains the same, ditto. There is no change at all. So for the main function, please note we have an encapsulation. See, the main function will not know whether the queue is implemented using an array or linked list. Okay, that's the beautiful thing about the that's a beautiful thing about tool-oriented programming. See, I did a lot of changes to the class, but the main function need not have to worry about it or even know about it. The main function will not even know whether the implementation is changed from uh, array to linked list. Okay, that's the beauty of the object-oriented programming. That is encapsulating the code in a class. So let's compile this. There is not even one error we found. So let's run it. Queue is created. Okay, then 2 you say the queue is empty, cannot delete an element. One thing that you have to observe is we have inserted element at the rear end, and we are also deleting the element from the rear only. So that becomes what, not a queue but a stack, isn't it? Right. So for time being, what we'll do is we'll change this class, we'll name it stack, because it is a stack. We have not at all implemented a stack. Okay, right, an empty stack is created. Okay, So wherever we have this, simply replace queue with stack. That's it. We'll change the name also to pop, and here push. Okay, change the names here also, push, pop, and this I've given the name as STK, and this is again stack. Okay, right? Here we'll say the stack elements are. So now here it will be stack, and here it is push, here it is pop, and here it's STK, and here also we will change the names, push, pop, display, stack. Okay, now compile this once. Yeah, here it is also stack. Compile this. It is compiled successfully. Run this. Okay, an empty stack is created. So now you say pop to stack display, the stack is empty. Okay, now you try to push, enter the node to be inserted. So what we will do, we'll say Hindi, Kannada, Tamil. Now display the stack Hindi, Kannada, Tamil. Okay, can you see it? Hindi, Kannada, Tamil. Okay, so for that what we will do, the display stack, we will give some space. Give some space. Now display Tamil, Telugu, again push, again display. Okay, again push, again display. So now you can see Hindi will be popped. The deleted data is Hindi. Okay, or the popped data is Hindi. Now you display, now you pop Kannada, now you display, now you pop Telugu, now you display, now you pop Tamil. Okay, all right. Okay, the deleted node is Tamil. Okay, yeah, fine. So now it is properly working, but there is, here we will say this popped data is, okay, the popped data, or we can say element. Okay, yeah. So now here when it is having only one node, so here we have to say written. That is very important. Okay, which we forgot. Okay, so that's it. So now let's trace this program. Let's trace the program. I hope you people are observing. Okay, anyhow, I'm going to trace this program for you. All you have to observe now. Okay, so first, as you can see here, I'm going to cut this. Assume this is not there, we'll bring it later. Okay, right. So these are all not required now. Okay, yeah, fine. So now say this is what we will have now at the beginning. What? The head will be null. Okay, right. So where this head will be? Inside the object. Okay, so inside the object. So this is the object. Okay, please note this is the object. I want you to observe. Okay, right. So this is, let us assume, obj, the object of the class stk, that is class stack. The object of the class stack is this in which it is having one variable which is a pointer and the pointer is of type node and it is null. Null means what? The linked list is empty. Okay, now begin. Now let's run this. So now it is showing us. Okay, so how it is showing? It has created a it has created the object in the heap. Okay, and it is being pointed by p. Okay, right. So how it will be? Please note this. Let us assume this is stack area. The left is stack area and this is heap area where the object is please note the object is here in the heap area and it is being pointed by the pointer p. So let us assume the address of this is, say, something like 9001 and this 9001 we have, what is this? P. Okay, right. Okay, fine. So we don't have this. Okay, now p is pointing to the object. Now is there a linked list? No, there is no linked list, it is empty. Now it is showing us the, okay, so we will say 1. Now when we said 1, so push function is called, okay, on the object. Now we are going to the push function. So we came here. As soon as we get a new node is created. So it is asking enter the data of the new node. Set data of the new node. So we will say Tamil. Okay. So then what happened? This new node. Okay. Say so this is created and it is here. Okay, right, and the data is here Tamil. Okay, the data is Tamil. So who is pointing to this? The head is pointing this. So mean to say what? The address in head is now it is 1001. So it is 1001. I hope you have understood this. Okay. Okay, so now we have like this. Okay, please note this is again null. This is not 3501. This is null. Okay, right. So where this became null, come here, see here. So as soon as we have created a node, we have made its link part null, then enter the data, then we are storing in the data. Now the node is ready. Now we have to store it in the linked list, that is in the stack. So what we will do, we will check if the head is null. Head was definitely null at the very, so head equals nn. Okay, right? So the new node, that is the address of the new node, we stored 001 in the pointer nn, so that we are copying it here. So please note there will be a pointer, okay, nn, and there will be one more pointer actually, temp. Later we will be taking it, okay, right? Okay, see, temp equals head. Okay, so temp was earlier, that is head was null, so temp will also be null. So this was 1001, nothing but the address of the new node that is created. Okay, so now we have, so please note these two nodes are not there. Okay, so let's simply delete stuff reading. So this is what we have now. Okay, right? Okay. All right, so this is what we have now. Please note these two are local variables in the function push. P is a local variable, all these three are pointers. Okay, right? So P is a local variable, it is a pointer in the function main. Nn is a pointer in the function push. Temp is also there in push and in some other functions also. Okay, right? So now it is one node is, so now I will say display. So the stack elements, let's see how it printed. So one node is already there, so what happens is the control will come back, so it will come to this break. Now it will throw outside. Now again this will be printed the menu. Now the user gave 3, that is display, so the function went to display. Okay, now it checked if head is null. As you can observe, head is not null. So what it will do, it will come here, temp equals head. So temp, in temp I'm copying what is there in head, which is nothing but 1001. Okay, so now continue. So what we are doing, while the stack elements are, it is printed temp not equal to null. Okay, temp is not equal to null, so it will go in of data. Now observe there, temp is 1001 here, of data is Tamil. Okay, right? Temp is 1001, that is what, of data is Tamil, so it has printed that Tamil, as you can see. Now next what happens, see here, temp equals temp of link. So temp of link is null, so temp becomes what, temp becomes null. Okay, temp becomes null. Now next what we are checking, well, temp not equal to null. See, we are checking for not equal to, but null we got, so it will skip. So it will go back to the main again. So now it is asking again, I'll give 1. Now I will give Telugu. Again I will give 1. So what has happened now I will tell you. Okay, so come here, we went to push function. So one node was created, a new node was created. It is having 2 parts, as you know. It is asking at the beginning what, enter the data of the new node. Okay, first we are making its link part null, so let's make its link part null. Okay. Right, now address of this, where it is stored in the nn, assume its address is 2001. So where we are storing it, here. Okay, so it is 2001. Okay, right, so 20. Now it will print what, enter the data of the node. Okay, here line number 44, enter the, okay. So now we said what, Telugu, right? Okay, or probably Kannada. Yeah, Telugu. So we will Telugu. Okay, right? So then what we are doing, once the node is ready, we have to place it in the linked list. Okay, so let's place it in this. So now we are checking if head equals null. So head is not equal null, it is 1001. So now next we are checking if there is only one node, how head of link equals null. Head is 1001, its link is null. Yes, there is only one node. So what we will do, we will say head of link equals nn. So head is 1001, of link here, what we are storing, what is there in nn what we have 2001. So store that 2001 here. So logically what it is, the first node is pointing to the second node. So this is how the nodes we will be adding. Okay, right? And now we have created probably one more node, so we'll add it, and let me delete the nodes for you. Okay, using the code. Okay, so there is one more, right? So this will be null. Assume its address is 3001. Okay, and this is and this will be 3001. Okay, now we want to pop. So in the pop function there is no new node, so let's simply, okay, so here it is 1001. Okay, so head is 1001 now. So now what is that, please note, we have this. So now we will say, yeah, we want to pop an element. So the popped element is Kannada. So how it worked, let's check. Let's go to pop. Now is head equals null? No, as you can see, head of link equals null. Head of link is head is 100, of link is 200. It is also not null. Okay, now next is we are taking temp equals head. So temp we have taken what is there in head. Now let's start. Traversing means we have to reach the next node, its next node, its next node, like that. Okay, we have to delete the last node. So now we'll do temp of link of link. Now the temp is 1001, of link is 2001, of link is 3001. It is not equal to null. So get inside, go inside the loop. So we are saying temp equals temp of link. So here temp, so the temp is now 2001, isn't it? So it is 2001. Okay, right? Next again equal to null. So temp is 201, off link is 3001, off link is null. Yes, null. So now we came outside. The popped element is temp of link of data. So what it printed, temp is 2001, off link is 3001, off data. So this Kannada, the node with data Kannada is deleted, or the element Kannada is deleted, it has said, correct? See there, the popped element is Kannada. Okay, so now what we will do here, delete temp of link. Temp is 2001, off link is 3001. So this address 3001 we are giving to delete. So what it will do, it will delete that node. So it has deleted. So now next what we will do, temp of link equals null. Temp is 2001, off link here what we are storing, null. So store null here. Okay, So this is how it works, and you have to, I want you to continue tracing the program like this. And today we have uh, implemented stack using linked list. So now I'll give you some assignments which I want you to do. Okay, right here. Okay, so now let's copy this. So what is this? Implement stack using linked list. Okay, हाँ 5. Okay, so now what are the programs that you have to do? Implement stack, which we have already done, using implement stack using linked list. Do both operations at front end of the linked list. Then implement queue using linked list. Okay, insert at front end, delete from rear. Then implement queue, insert at rear, delete from front. Okay, so this is what you have to do. Okay, these three programs you must try. Okay, now tomorrow, that is 2nd March 2018. Okay, what I'll do, we will try an example on doubly linked list, and we will also add and delete nodes in between. This is what we have, this is what we will be doing tomorrow. Okay, I hope you have understood this program. I want you to go back and trace the program. That is very, very important. Okay, if two people, if two students sit together and trace the program, that will be better. Do not forget to write the diagrams like this. Okay, right? See, you may take time, it may take time, but your effort will surely bring the results, good results. So please trace the program. That's very, very important. Okay, yeah, thank you for the day. Thank you. I'm going to stop now. Let's meet tomorrow. Thank you.